Welcome to lesson 6. In this one we're going to be talking about working with decimals in our word problems, and then also we're going to be looking at consecutive integers, consecutive odd integers, and consecutive even integers. So starting with the first part of dealing with decimals in our word problems, if you've ever taken a math class from me before, you know the two things I despise most in the math world are fractions and decimals because they make equations very messy. So anytime I can, I want to get rid of the fraction or the decimal. And the way that we do that is we multiply every term in the problem by a power of 10 based on our deepest decimal. So in this case, I have 1 decimal place, 2 decimal places, and 3 decimal places. So this one's my deepest decimal. And so I'm going to work with a power of 10. I have 3 decimal places, so I'm thinking 10 to the 3rd power, which is 1,000. I'm going to multiply this whole problem by 10 to the 3rd power, or by 1,000. And when I do that, I can just slide this decimal over. So I'm going to start with the deepest. If I move that 3 times, this now becomes 1. And so if I'm going to move this one 3 times, notice that we're missing a spot. So this will actually become plus 10. And with here, it's going to become 100x. And so just like that, I have no more decimal, and it's much more simple to solve. And so now that you've seen that, let's do a practice. Okay, so in our first example, we're going to look for our deepest decimal place. And so I have 3 decimal places, 1 and 2. So this one's my deepest. I'm going to multiply everything by 10 to the 3rd because it has 3 decimal places. And now, as I distribute this 10 to the 3rd power, I'm going to move the decimal place 3 times on all of these terms. So to move this 3 times, it will be just 3x plus 400 equals 2050. Okay, now that we've done this, we're not done. We just got rid of our decimal. The problem still wants us to solve, so we still need to get x by itself. So I'm going to move the 400 by subtracting, change side, change sign, and now we have 3x equals 1650. And now we're going to divide by 3. And x is going to equal 550. And we're done. Our next example is still the same concept of dealing with decimals in our equations, but now they're also a word problem. And so before we start piecing all of this together, I do want to mention our basic equation that we're going to work with when dealing with decimals. And it is going to be what decimal times of equals is. Very similar to what we did in our previous lesson when we were dealing with fractions in our word problem. Same concept. Instead of putting the fraction here, you're going to put the decimal part, and that's really all there is to that. So let's do this practice problem. So it says the students found that 0.015 or 15 thousandths of the teachers were either brave or completely fearless. If 300 teachers fell into one of these categories, how many teachers were there in all, or total? So we know our decimal part is going to go first, okay? And then we're gonna have times and is. We don't know our total. That's what they're wanting us to find. So this is gonna be my x, my unknown. But we do know how many teachers fell into this category. It's 300. And so this one, I don't actually have to do what I did in the beginning part of this lesson, because in this case, I'm just going to divide by 0.015. So I don't have to worry about multiplying my entire equation by a power of 10 to get rid of the decimal, because this is the only decimal I'm dealing with, and it's about to get resolved right now. So our total number of teachers is 300 divided by 0.015. So 20,000, that is a very large school, but sure, okay, we'll go with that. So 20,000 teachers. Our second concept in this lesson is dealing with consecutive integers, and I find the way to best grasp this is to think about a number line. So when we're talking about consecutive, that means one right after the other, immediately after the other. So if a certain team were to win back-to-back state championships, that would mean they won 2 years in a row, consecutive state championships. And so when we're dealing with this, when we're talking about consecutive integers, We also have to remember an integer is either a whole number or it's negative. No decimals, no fractions, no irrational numbers. Pi is not included in this. It is stuff that does not require a fraction or a decimal. Integers only. And that will also help you in quick checking your work. Is if you ever have one of these problems and you end up with a decimal, we did something wrong and we have to check our work. So in looking at consecutive integers, let's say my first integer that I'm working with is 0. So my first number is 0. How do I get to my next consecutive integer? How do I get to 1? By adding 1. So it's my number, my same number, plus 1. Okay, how do I get to the next consecutive integer? Well, in this case, I'm going to add 2. So n plus 2 will get me my next consecutive integer. So that is the layout that we have to remember when they're asking for consecutive integers. I'm going to write this over in the corner just so we can remember it. The other type that they'll ask us to find is not consecutive integers, but consecutive odd integers or consecutive even integers. So let's say our first integer was -3. How do I go from -3 to my next consecutive odd integer? To go from -3 to -1 is to go plus 2. So I would say n plus 2 would get me my next consecutive odd integer. Okay, how do I go to the next one? I would go from -3 to +1. That's plus 4. So this is our layout that we do when we are working on finding consecutive odd integers. But something that I want us to remember is that this also works when we're looking for consecutive even integers. So let's say we are starting with 0. And we are wanting to go to our next consecutive even integer. That is plus 2. And if we want to go to our next one, that is plus 4. So notice that for consecutive odd and consecutive even, we're using the same setup. Even though one is odd and the other is even, if we're wanting consecutively, we have to go every other number. That's why this has to be n plus 2. And what I've often seen is n plus 1, n plus 3, and that's not going to get us consecutive odd integers. And so both of those require the same setup. Okay, so let's do some practice. In this example, it says, find 3 consecutive even integers such that 5 times the sum of the first and the third is 16 greater than 9 times the second. And this is why we have this setup, because they're going to say the first, the second, and the third. And we know that n is our first, n plus 2 is our second, and n plus 4 is our third. And also notice that we have labeled that this is the same for odds and evens. If you need to put this on your formula sheet, I totally understand for the beginning, just as we get used to this. But I do expect at some point that you don't need to write down that information anymore. So finding 3 consecutive even integers such that 5 times the sum. Okay, so 5 times the sum of the first, so the first one is n, and the third is n plus 4. So we have 5 times the sum of the first and the third is means equals, is 16 greater than 9 times the second. Well, let's find 9 times the second. So 9, and we're going to do parentheses here, because I don't want to just say 9n plus 2, because it's not 9 times n and then plus 2. It's 9 times the second term, this whole thing. So that's why I need to put this in parentheses. Parentheses are going to be so important this entire school year, so just go ahead and accept that fact now. So 9 times the second, but it says it's 16 greater than. So we got 16, and since it's greater, we're going to put a plus sign. So now we have taken this from a very intimidating word problem, and now it's just a simple equation where we just have to get n by itself. So I'm going to go ahead and add this together. This is going to be 2n plus 4, and I'm going to distribute the 5. Okay, and then I can add 16 and 18 together. That is going to be 34. Okay, and now we need to get our variable on one side, our numbers on the other. I'm going to move this by subtracting, so minus 9n, and then minus 20, and we're left with n equals 14. Okay, and now I'm going to start asking myself some questions again. What was the question wanting me to find? It said even integers. Did I get an even integer for my first question? Yes, I did. Okay, so we're off to a good start. But it wants 3 consecutive even integers. So what comes after 14? Well, 14 plus 2 is 16. And 14 plus 4 is 18. So whenever I'm writing this answer down for my homework or for a test, I'm not just going to put 14 because that's not what the question is asking me to find. They want find 3 consecutive even integers. So I would write my answer like this. Let's say this was problem number 3 on my homework. I would write problem number 3 and then 14, comma, 16, comma, 18. And that is how I would write my answer. Okay, so let's take a look at another practice problem. Find 4 consecutive integers such that 5 times the sum of the first and the fourth is 1 greater than 8 times the third. Well, first off, my setup for consecutive integers only has 3, so I'm going to have to change that. Okay, now I can find 4 consecutive integers such that 5 times the sum of the first and the fourth. So first I need to write the sum of the first and the fourth. Our first is n, and our fourth is n plus 3. And they're wanting to multiply the entire thing by 5. So 5 times the sum of the first and the fourth is means equals, is 1 greater than 8 times the third. So what is the third? The third is n plus 2. But it says 8 times the third. And then it also says it is 1 greater. So I'm just taking one piece at a time and setting up this whole equation. I'm not trying to do this all in one go. I'm going piece by piece. I'm going to simplify this to 2n plus 3. And then I'm going to distribute the 5. Okay, and then I also see that I can add those two together. We're seeing a lot of similarities from our last problem. I don't know if you noticed that. So we have 10n plus 15 equals 8n plus 17. And now we need to get n to one side and our numbers to the other. So minus 8n and minus 15. And we get 2n equals 2. But we need to get n by itself still, so divide by 2. Ooh. And then that reduces and we see that n equals 1. But that's not where we are supposed to stop because it says find 4 consecutive integers. Right now I only have 1. So what integer comes after 1 is 2. So if this were problem number 4 on my homework, I would write 1, 2, 3, 4. And I have 4 consecutive integers. And that is all for lesson 6. And so we're done. I'll see you guys in class.